Hello everyone, welcome to engineeringtalks.com. Today's topic of discussion is crystal versus lattice. A crystal is not a lattice. Or in other words, a lattice is not a crystal. There is a widespread confusion between these two terms. Though these two words are often used synonymously in colloquial language, they are different. So, what is the difference between a crystal and a lattice? Let's find that out. While we figure out the difference between these two words, we will also get to know what is meant by a motive. So, what do you mean by a crystal? A crystal can be defined as a three-dimensional periodic arrangement of atoms or ions or molecules in space. Let us consider an example of a sodium chloride crystal. Sodium chloride is a common salt. Here I have shown the unit cell of sodium chloride crystal. Here you can find a three-dimensional periodic arrangement of sodium and chloride ions in space. The black ones are the chloride ions and the orange ones are the sodium ions. In the unit cell of a sodium chloride crystal, as you can see, the chloride ions are present at the corners of the unit cell and also at the face centers of the unit cell. Whereas the sodium ions are present at the edge centers. As you can see, the sodium ions are present at the edge centers of the unit cell and also at the body center. So here, what is meant by a periodic arrangement of sodium and chloride ions, or generally periodic arrangement of atoms or ions or molecules in space? Just look at this figure. Here we have a chloride ion. After a particular distance, we have a sodium ion. Then after sodium ion comes the chloride ion. So if we move along the edge, after the chloride ion, we will be able to see the sodium ion. Then comes the chloride ion again. Then comes the sodium ion. So if we move along this edge, we will be able to find out this pattern being repeated. Suppose we move along the phase diagonal. Along the phase diagonal, we have the chloride ions being repeated. So, this is the periodic arrangement of sodium and chloride ions represented by the unit cell. So, if we move along the edges and the phase diagonals in different directions in space, we will be able to find out the similar patterns being repeated. So, the unit cell is actually the fundamental building block, we can say, of the crystal. So, the unit cell can be defined as the fundamental repeating structural block or unit which contains all the structural and symmetry information about the solid or the crystal. So this unit cell acts like a single puzzle piece using which we can actually build the crystal. A crystal is a tangible solid, right? A crystal is a macroscopic visible object, and that is formed by stacking billions of these unit cells in all directions in a repeating grid. Let us now discuss the concept of a lattice and how it is different from a crystal. We now know that a crystal is a three-dimensional periodic arrangement of atoms or ions or molecules in space. A lattice is defined as a three-dimensional periodic arrangement of points in space. So the only difference lies in whether we are considering the points or the actual atoms in space. Otherwise, both are three-dimensional periodic arrangement. So this lattice gives us the underlying structural geometry. It is the framework or scaffolding upon which the crystal is built. If we replace the points with the actual atoms, we get the actual crystal. So here I have shown a 2D square lattice, and this is a 3D cubic lattice. So here these are points known as lattice points. These are not the atoms, these are lattice points. Once we associate each of these lattice points with the actual atoms or ions, we get the actual crystal. So what are the differences between a crystal and a lattice? A crystal is a three-dimensional periodic arrangement of atoms or ions or molecules in space, whereas a lattice is a three-dimensional periodic arrangement of points in space. Crystal is a tangible solid, right? It will have physical properties. So it is a tangible solid. It has physical properties. So it will have physical properties. Is a lattice a tangible solid? No. So will it have any physical property? No. So it doesn't have any physical properties. So no physical properties in the case of lattice. Since a crystal exists physically, we can weigh a crystal, we can measure its density, we can measure its thermal or electrical conductivities, which is not possible in the case of a lattice because it is a concept. It is used for visualizing symmetry and unit cells. So we can note down that difference as well. So crystal exists physically. Lattices are conceptual and are used for visualizing symmetry and unit cells. Since the lattice is a geometric concept, it will have geometrical properties. Now that we have seen the distinction between a crystal and a lattice, it's time to know the relationship between these two terms. We should know how they are related. So the relationship between a crystal and a lattice is given by the equation crystal is equal to lattice plus motif or basis. Motif is also known as basis. So this motif is actually the linking bridge between a crystal and a lattice. So what do you mean by a motif? A motif can be an atom or group of atoms associated with each lattice point. So when we replace each of the lattice points with motif, we get the actual crystal structure. So every crystal will have a motif and a lattice, or a lattice and a motif. So what is a motif? So a motif is actually an atom or group of atoms associated with each lattice point. So these lattice points have to be replaced with the motif in order to generate the actual crystal. So it is placed on each lattice point to generate the actual crystal, to form the actual crystal structure. So a crystal is equal to lattice plus motif or basis. So every crystal will have a lattice and a motif. So we can write every crystal has a lattice and a motif. Let us now go through the differences between a lattice and a motif. We all now know that a lattice is a three-dimensional periodic arrangement of points in space. And what does this tell us about the crystal actually? We are able to understand the underlying periodicity of the crystal structure with the help of a lattice. Whereas a motif is the actual contents associated with each of the lattice points. So it can be atoms, group of atoms or ions or molecules associated with each lattice point. And these atoms are periodically repeated to form the entire crystal structure. So for lattice we can write it is the periodic arrangement of points in space, and we are able to understand the underlying periodicity of the crystal with the help of a lattice. So underlying periodicity of the crystal structure. Motif, it is the actual content. We can write the actual contents. It can be atoms, group of atoms, ions or molecules associated with each of the lattice point. With each lattice point, so these atoms are periodically repeated. So we can write actual contents that are periodically repeated. So a lattice tells us how the structure repeats, whereas a motif tells us what is being repeated. So that also we can write it down. It tells us how the structure repeats. Motif tells us what is being repeated.
If the motif represents a single atom, then the lattice points coincide with
the positions of the atoms. But if the motif is a group of atoms, then the lattice points often represent a geometric center rather than the actual positions of the atom. So we can write, if the motif is a single atom, then the lattice points represent the actual positions of atoms. And when the motif is a group of atoms, the lattice points represent a geometric center rather than the actual positions of the atoms. Here we have an example of a 2D lattice and a motif. So here we have a star pattern. Here stars are periodically repeated in 2 dimensions, horizontally as well as vertically. This pattern of stars is like a crystal, right? So if we want to decompose this pattern of stars into lattice and motif, let us place a dot at the center of each of these stars like this. Now if we remove this star pattern from this, we will get a pattern like this. So this is not our actual pattern, but this is the lattice of our actual pattern, that is a star pattern. So this lattice tells us how the stars are being repeated in different directions. If we associate a motif with each of these lattice points, we get the actual pattern. In this case, our motif is star. So we have to place a star at each of these lattice points in identical orientation to get our actual structure. Here in our case, the actual pattern, that is the star pattern. So this is like lattice plus motif is equal to crystal. So the same process can be employed in the case of 3D crystals as well. So this is all for today's lecture. Thanks for watching.